Hey, good morning, everyone. Miss seeing your faces, and I hope everybody's doing well. I'm making a little test video for us to see how this is going to go, and I figured we could start reviewing everything for AP Chem, starting with big idea number one, properties of matter. So on your screen, you see, what is this? Come on, what is this? You should be shouting Coulomb's law, right? Where the force that exists between charged particles is equal to this equation, Coulomb's law. The magnitude of the charges divided by the radius squared. Okay, so making videos at home and teaching you guys. Obviously, this is going to be a lot different from the classroom. We'll try it out. We'll see how it goes. I can lock myself in a room if I need to, but we may have any amount of random house chaos going on in the background. All right, the very first learning objective is about the ratio of masses in a sample, right? The foundation of chemistry, the idea that everything is made up of atoms. Compounds always have the same ratio of elements in them. And so what does that look like as a question on the test? I will be linking this whole entire PowerPoint that has the review of everything, where you guys can go through it at your own pace. But we'll go through a little bit of this together. So what kinds of questions could we see here related to this? We could see things like percent composition, determining the empirical formula. A lot of the questions that are built into this PowerPoint are all multiple choice questions, but these are the exact same skills that you have to be able to incorporate for the free response questions. You know as much as I do about what the exam is going to look like now. We don't know that much, right? It's going to be 45 minutes. It's going to be all free response. It's going to be, hey, Coda. Kitty's trying to say hello. It's going to be something that you do at home on your phone or on your laptop or whatever. So yeah, as we know more, we'll figure out what we're going to do from there. But it's all going to be free response questions. But of course, the questions that you see on here are going to help you as well too. So 4.5 gram sample of which of the following would have the greatest mass percent of oxygen? Well, what's the skill that you have to be able to apply here? We just need to know how to calculate mass percent. You're given 4 choices. You are given their molar masses. There's not a lot of thinking. You can pause this here and see if you can figure out what the answer would be. So you might be tempted to just pick the one that has the most oxygen atoms in them, right? One oxygen, one oxygen. Oh, look, they all have one. That's not going to help you here. What you really want to pick is the one that has the highest percent oxygen by mass. Well, here the molar mass of this compound is 62. Oxygen makes up 16 grams per mole of that. So the rest comes from the sodium. So what's your answer going to be? Right? Hopefully you're going to pick the one. So 16 is the mass of oxygen. The total is shown here for each one of these. So the oxygen makes up the highest percent of B, lithium oxide. Your lithiums don't have a large mass, right? Lithium has a mass of about 7. And there are 2 of them, so all together we have a molar mass of 30 grams per mole. And yeah, you can pick that out. You could calculate the mass percent. You could use the percents to calculate the empirical formula, and very often we're expected to do that as one tiny piece of a multi-part free response question. Okay, so the second learning objective talks just about that, right? Empirical formula, molecular formula. Let's look at a question. A compound is determined to contain 14 grams of nitrogen and 32 grams of oxygen. The empirical formula of the compound is, well, I think you should pause the video right here and do the calculation. Okay. You need to start by, so if you've restarted the video, or if you're just cheating and didn't pause it, how are we going to start? We're going to start by taking this 14 grams of nitrogen and this 32 grams of oxygen. And we need to change those to percents. Once we know the percent nitrogen and the percent oxygen, then we know how many grams would be in a 100-gram sample. We can convert that into moles. We can find the mole ratio. And I'm sure you already did that while the video was paused. So let's do it. Let's do it. Let's changing those to moles and finding the mole ratio would tell you that you have 1 nitrogen to every 2 oxygens. And so, no, you all got that right. So, high five, congratulations, good job. What about the purity? This will be the last one we do for our short little sample today, our short little video to try this out. So, you probably recognize this setup. What is this? This is a Bunsen burner with a crucible and a copper compound. Copper sulfate is a hydrate. It starts off blue, and when you heat that, it turns white. You remember that from Chem 1 lab. It turns white as you lose the water. You can calculate the grams of water that were lost and change that into moles and figure out how many moles of water are attached to each mole of the compound. This learning objective 1.3 takes that a little step further and asks you to consider the purity. If you have an impurity in there, it's going to change those expected ratios. If we had a contaminant in there that was high in oxygen, then that could throw off what we think our percents are. So the mass percent of oxygen in pure glucose is 53.3%. Chemist analyzes a sample of glucose that contains impurities and determines the mass percent of oxygen is 49.7%. Which of the following impurities could account for the low mass percent of oxygen in the sample? And so pause the video here. Think it through. What do you know? You've got an observed percent oxygen that's lower than it's expected to be in pure glucose. You have 4 choices here of compounds that have differing amounts of oxygen in them. Which one of those as an impurity would lower the observed percent oxygen from what's expected? And so we would want to pick the one that has the lowest percent by mass of oxygen in it. And of course, that's going to be the one that doesn't contain any oxygen at all. And that is choice A. And I'm sure you got that right. So great job. And we'll stop with this for today. I just wanted to make one tiny little video, let you know what some of this review is going to look like. I do hope to get this on an iPad so that I can work out the problems and you can watch the steps, or I can use the document camera. So I'll be trying several things out and getting some feedback from you guys. Would love to hear from you. Would love to know how you're doing. So stay in touch and have a good, well, I don't know if we can have a good what's left of the year, but let's do some work and learn some things and get smart.